Okay, 2022 applied maths. So today's applied maths paper, relative velocity questions. So you've ships, and then you have this rather unusual generalized version of the river crossing. So that should be interesting. This one is fairly standard, I would think. So let's have a look at that. Ship traveling 22 in direction west, so much north. So the ship is traveling 22 kilometers an hour, and it's 30 degrees, it's west, 30 degrees north. So that's north, that is west, that is east, and that's south. Okay, and so both sets out to intercept 25 kilometers. So it's 25 kilometers south. So that's the ship, this is the boat. 25 kilometers in between them. Speed of the boat is 55, so that's to intercept it. So you need to draw your triangle. So that's going at 55. Now, because we have this distance here, we're going to have to, the speeds, convert them into distance by saying t. So they set out, that sets out from here at t0. That sets out from there at t0. So after t, then these are the distances that'll travel, 22t and 55t. Okay, that is going to be 90 degrees, so we now know that full angle there. Okay, so that full angle there is going to be 120. 22t, 55t, and that's 25 in absolute terms distance. Okay, direction the boat should steer, so that's this alpha angle there. Okay, so sine rule, let's see what the sine rule will do for us. So sine of that angle 120 over 55t is equal to the sine of angle alpha over 22t. Okay, that looks fairly straightforward. So sine of alpha then is going to be 22 over 55, which is nice. Sine 120. Sine 120 sounds fairly nice. Is it going to be, is that 180 minus 60? So reference angle of 60. Which is what, root 3, what's that triangle? Root 3, 1, 2? Yeah, so, and all sine tan cos, so it'll be positive, yeah, so it's the same as that. Okay, so that seems fairly straightforward then. So that sine alpha is equal to 2/5 of sine 120, which would be root 5 over 2, is it? God, that looks nice and even. So those cancelling. So 1 over root 5, yeah? Is that right? Yep. 1 over root 5. Okay, so what's that look like? That angle alpha. Well, root 5. It's 1 over root 5, so that's root 5. That's 1, which makes that what? 2? Is that correct? So it'll be 4. Yep. Yeah, so it's 4 plus 1. Yeah. Okay. So, which makes that angle what? Let's see. So root 5 over 2. Let me see. Is this correct? Okay, so this, is that right? First of all, 60, it's not. That's root 3. What am I doing? That's root 3 triangle. So it's root 3 there. Yeah, because I knew there was something wrong, because that would have been a sign bigger than 1. So it's root 3 over 2. So it's root 3 over 5, is it? Sine alpha is equal to 2/5 root 3 over 2. So it's equal to root 3 over 5, which is not going to be any one of the standard triangles by the looks of it, unfortunately. Root 3 is what, 1.71 or something over 5. Okay, so pop it into the calculator. It's not going to be any one of those nice ones. But can't get it, have it all the way all the time. Let's have a look. Root 3 over 5.7 divided by 5.34. Sine alpha is 0.34. Just about a third. Let's put it into an inverse. Sine inverse 0.34. Radians, where's my degrees? Uh, 19.9, yeah? 19.9. Okay, so alpha is 19.9. Seems all right. Okay, so that now gives us all the angles. So that's 19.9, that's 120, so we now have that angle there, which that's about 20. So that's 40.1, is it? Is that correct? So that's 60, yeah. Okay. Grand. Now, so they're asking us time to, okay, so the direction the boat should steer, we have that now, but by the angle 20. So we're saying the boat should now go north 20 degrees west. Okay. Now we're asked time to the nearest minute it takes the boat to intercept the ship. Well, so that'll be equal to t. Okay, so let's go nuts on the sine rule again. So sine, okay, and we have this one here, 25, that's great. So sine of 40.1 over 25 is equal to, we have this guy, yeah, 55t is equal to sine 19.9 over 55t. So we have everything there, so we can find t of that. So so 55, was that 25? It was, yeah. So 55 over 25t is equal to sine, that guy, 19.9 over sine 40.1. I think we have both of those, don't we? Well, we have sine alpha, which was that one. So we have that 0.34. Grand. And we need to get sine of that 40.1. Okay, so 40.1 sine of that 0.644. Yeah, 0.64, let's say. So t then is equal to 5/11, yeah. By that guy over that guy, but that's about a half, I suppose. 0.34 divided by 0.64. Yeah, about a half. Multiplied by 5/11. We get 0.24. 0.241. So T is equal to 0.241. Yeah, 0.24. So that is in terms of hours, and we're asked for the nearest minute. 0.24 hours. So just multiply that by 60 to get the nearest minute. And what's that? So it's about 14. So T is 14.5 minutes. Okay. Grand. So a distance between the boat and the ship 10 minutes before they meet. Okay, that's a bit of an odd one. So where's that? So 10 minutes before they meet. So the distance there, 10 minutes before they meet. So we know when they do meet. So the distance before they meet. Okay, so do we have to get the relative velocity? Yes. Okay, so so we have the boat, velocity of the ship. So that's 30 is equal to minus so it's minus i's, so what's that? Cos 30, so it's 22 cos 30 plus 22, so that's I, plus 22 sine 30 j. Velocity of the boat is equal to 55. What does that look like? Yeah, we have the angle, which is 20. So where's the angle? 20. So that's 70. So that's 70. Yeah. So that angle is now 70 there. Minus 55 cos 70 I plus 55 sine 70 j. Okay, so the velocity of the boat relative to the ship subtract that, so velocity of the boat minus the ship. So we get the velocity of the boat relative to the ship. Grant. So then we have, okay, this guy. We know they're initially 25. So velocity of the boat relative to the ship is going to look something like that, let's say. The boat relative to the ship, they're going to, okay, so 9 to the nearest minute, it takes distance 10 minutes before they meet. Okay, so 10 minutes before they meet, how long did it take? Okay, which is 1/6 of an hour. Okay, how long does it take them to meet? Okay, we said 0.24 hours. So T meet is 0.24 hours. or, hold on, 14.5 minutes. So it kind of verifies that answer. And we're now saying 10 minutes before that. So the distance between them at 10 minutes before that. So in other words, the distance after t is equal to 4.5 minutes after they set out. So the distance between them then. Okay, so right, so the distance between them at the start is 25 kilometers. And basically it travels for t. So that's the distance between them at the start. The time they're traveling is 4.5 minutes at a velocity of VAB. So what's the distance going to be? So the distance is going to be so distance is equal to velocity by time. So the distance would be equal to 25 minus VAB times the 4.5 minutes. Okay, so that's the distance between the boat and the ship 10 minutes before they meet. Okay, grand. Now, so we just have to make sure that the minutes and the hours are in the right format. So the 4.5 minutes in terms of hours is 4.5 over 60 hours. So that's how long it's been traveling. That's how long they would be traveling for that. So just have to factor that in. Okay.